Sorry, camera died. So the idea works, but just not to my liking. And sometimes, it would push the button out on an angle and would just get stuck, so you wouldn't really know whether the blade is held on or not. So I had a problem with that, and this is, like I said, it's a prototype. All is a trial and error, and you work out the kinks. So that was prototype number 1. I mean, it works. Sometimes it stays cocked to one side and just doesn't want to release. You see that? So it works well with the blade, just not to my standards. See, it's not locked right now because this is crooked. This is crooked. So you have to jiggle it a little bit, jiggle it a little bit, and it'll eventually lock. If you play around with it enough. But this is just so finicky, I don't like it at all. There you go. Nope. Yeah, so this whole system is very finicky. I don't like it at all. There it goes. It locked. Finally. Jeez. So I had a big problem with that. Big problem with that. The whole design and the whole idea. So that's that. Prototype number 1. Let's look at all the scrap pieces that I accumulated, and I don't think this is all of it, honestly. There's so many buttons here because I do, I believe, about 6 at a time for the first operation or something, and that's just what it is. See, sometimes it would get too thin. Whatever. These are the latches. These are the basic design of the latches. Reamed hole. That's all it does. This one's missing the cutout there. See, it's missing the cutout. That's okay. This is supposed to fit in there. Perfect. Supposed to fit in there perfect. Now, what I have to do with these is hand file off some of these corners here, and maybe take a thou or so off of here, maybe a little bit off of there, so it gets real nice catch, and it doesn't stick. So I have to basically take it out, file it, touch it up until it gets a real smooth in and out action. So the machine actually holds this tolerance really tight. This here, the thickness here, I have it set at I think like 1.177 or something, and the machine actually holds it well within a thousandths, because this thickness is extremely critical to how this all works. So all these parts are scrapped and prototypes and blah blah blah. So that goes into a scrap bin or a scrap bag, so I don't get it all mixed up. Yeah, tooling. Let's take a look at the tooling real quick. I ordered a bunch of reamers. 126, 1243. So 370, 374. These are for the new design, for the second design. 1248. So if I were to, or when I do titanium, these are the ones that I'm going to need, because titanium press fit, or if I decide to do press fit, it needs to be a lot less than, lot less clearance compared to this one. So I need a bigger hole to press fit pins in titanium. And remember, titanium holes like to shrink in on the drills and reamers. So, reamers, reamers, reamers. Dovetail. This is what I use to cut those angles. 60 degrees. Yeah, it looks like 60 degrees. I forget. And to do a lot of the features, you know, I use something like this. This is a 2mm end mill. So that's a 0.79 thousandths. 0.79, 0.80, whatever. 0.80 4 flute. Aluminum titanium nitrate coated. It's 4 flute. Yes, 4 flute. For titanium. So this is not really meant to cut aluminum, but it works for now. It's prototype. But yeah, pretty small. What else? What else? Hardware. Hardware for all this prototyping stuff. Some 832 sockets. That's for Rev 2, revision number 2. These little things, man. I think these are the mil spec flathead screws. You buy one each, one pack, one each. They're supposed to be very, very tight tolerance, so a lot better that way. Some more screws. These need to be trimmed to length, I believe, on the new design. These are the low head, low socket head. Usually the regular socket head would be about that thick, but these are better because all my thicknesses on the blade, on the knife itself, is pretty thin, so low heads are good. Dowel pins, more dowel pins, more dowel pins. And this was the bearing that I bought. It's a radial bearing. You know, I thought it would be good to use one of these, but prototype number 2 will say otherwise. Radial bearings. It works real good radially. Yeah. That's no good also. I'll show you why. So the idea of pressing in all these pins into the frame is difficult because you need it perfectly perpendicular to the surface. And I have a little Harbor Freight press over there. They're not that great, not very straight until you tighten up all the bolts. So here's a little thing that I turned up real quick. This is for the bearing. This is to press fit the bearing in. I don't think I'm gonna need this for revision number 3 of 3, I hope. So yeah, this is a bearing presser block, I guess. I don't know, what do you want to call it? So this is nicely turned also. So this surface and this surface is parallel, and then I just use some magnets to put it on there and stick it on, so that I don't have to, you know, mess with putting a set screw in there and cutting a pocket for the press. So magnets are awesome. So this is the one that I made, again machined on one side and the other side so that they're parallel, so that when I push in the pins it's perfectly straight. So the idea is to have, I got these little tiny magnets in here. So let me get a pin here, because it's hard to press fit pins straight. Even though you ream the holes, I didn't ream the holes all the way through. With the through hole, you will be able to get these pins in straight. Even if you hammer it, it'll straighten itself out. But I'm not going all the way through. I'm only machining about 100 thou deep. That's not much at all, especially to try to keep this pin from, you know, wobbling around or whatever. So this is a little fixture that I made, you know, just a drill hole with a 1/8 drill. And when you drill it, it usually comes out big, so I know that's not a problem. So it goes in, sinks in a certain amount. It's a calculated amount. The depth is calculated amount. I just put the